Hello class, in this video I will be introducing the inverse sine function. Let's begin. And before we are able to graph the inverse sine function, I have a couple of reminders. First reminder, a function is said to be one-to-one if every value in its range corresponds to only one value in its domain. Reminder number two, if a function is one-to-one, then it has an inverse. The converse of that statement is also true, and it's reminder number three. If a function has an inverse, then it's one-to-one. So what I'm going to do is I'm going to use the information highlighted in blue along with the graph of the sine function to graph the inverse sine function. To graph the sine function, I'm going to start by plotting the key points. 0, 0, pi halves 1, pi 0, 3 pi halves negative 1, 2 pi, 0. Next, I'm going to extend this graph in both directions. And then connect the points with a smooth curve. And now that we're done with the graph, let's go ahead and analyze what's happening. So along the horizontal axis, these values represent the angles, theta. The vertical axis represents the ratios. And you may notice that the graph of sine of x shows that sine of x is not a one-to-one function. So sine x is not one-to-one over its current domain. And I know that because I could place a horizontal line anywhere along this graph. I'll just place it through the range value of y is equal to 1. And that range value has 3 domain values. So clearly sine of x is not a one-to-one function. However, what we can do is we can restrict the domain of sine of x so that it will become a one-to-one function. And how are we going to do that? Well, I'm going to start at the origin. And notice that if I start at the origin and I travel to the right, the graph increases. And then after pi halves, the graph will start to decrease. And if I were to place a horizontal line right there, that range value has 2 domain values, which means if the graph extends past pi halves, then the function is no longer one-to-one. So I'm going to restrict the domain so that the angles are not greater than pi halves. So we're going to erase that part of the graph. Okay, going back to the origin, if I travel to the left, I go down to negative pi halves comma negative 1, the function's decreasing, then it goes back to increasing. And if you draw a horizontal line, which represents a range value, this range value has 2 domain values. So if the graph extends to be less than negative pi halves, sine of x is no longer one-to-one. So I'm going to place another vertical line at negative pi halves. And we are going to completely ignore this part of the graph. Now, if you take a look at the part of the graph that is remaining, this part of the graph is a one-to-one function because I could take this horizontal line, which represents range values, and each range value now has only one domain value. So what are we going to do with this? Okay, I'm going to make a table of values for sine of x. And that table of values is over here to the left. And notice the first column, the input values, are the standard angles on the unit circle. These angles at the top are in quadrant 4, and these angles at the bottom are in quadrant 1. So for sine, you are going to input angles and output ratios. Well, what about the inverse sine function, which we call arcsine? So arcsine or inverse sine. Well, to create the table of values for the inverse sine function, I'm going to reverse the ordered pairs on the table on the left. So I'm going to do that now. And for the inverse sine, the input values are ratios, and the output values are angles. And again, the angles are on the unit circle, where the angles at the top are in quadrant 4, and the angles on the bottom are in quadrant 1. To graph the inverse sine function, I'm going to plot these 3 coordinates that are starred because they are the easiest points to plot. Okay, so x represents now ratios, and y represents the angles. And the first coordinate we have is -1, negative pi halves. The second coordinate is 0, 0, then 1 pi halves. And there is the graph of inverse sine of x.